Hey everyone, so we're gonna do continue on with our log expressions. This time we're actually gonna talk about how we're gonna do what we've been doing with logs, but adding in equations. So we're gonna learn how we can take the whole expanding and compressing and turning in, going from logs to exponents and exponents to logs, all together to get solving for x terms. All right, so quickly, this is just a refresher on how we solve for x. Remember, the way we go between logs and exponentials is we take the base term, move it over, drop the log, and this becomes x equals 3 cubed. If you plug that into the calculator, 3 cubed is equal to 27. So here we have a log, x equals 27. So log base 3 of 27 is equal to 3. All right, so really quickly, we have a few things to mention, some terminology to go over. We actually have a name for logs that are naturally base 10. Remember, when we write a log like this, we're assuming that you know that this is a base 10 log. So this type of log is actually called a common log. Because it's so common that's why we just state that it's base 10. So again, in the example here, log 8 has a base of 10. Now, an interesting thing is that if you go into the calculator and you do log of 10, you get that log 10 equals 1. This is actually true for anything, that if you take the log of a number, we'll say b, and that number matches the base for that log, it always equals 1. So if we had log base 2 of 2, that's equal to 1. And we could see that by rewriting this into an exponential, that it makes sense. Moving the base 2 over, we get 2 equals 2 to 1. So yeah, that's true. Now, there is another type of log that we have a special name for, and this is a logarithm with a base of e. This is called natural log. What we usually do is that instead of writing log base e of some number, we instead combine this and say that we rewrite it as ln, which is standing for natural log. So here's an example of how you'd write natural log. So ln 8 has a base of e. Now, if you go in the calculator, you can plug in the value for e, and we see that e equals 2.718281828, and ln of e is equal to 1. And remember what I said before is that when you take the log of a number that's equal to the base, it always equals 1. So that's why ln of e equals 1, is because ln is a natural log which has a base of e. So we're taking log e of e. Now, that's important to remember, because if you ever see a log or we're doing something with ln, you have to know is that there is a base written in there, that when it's written as log, base 10, when it's written as ln, it's base e. All right, so the way that we're going to solve these is to first rewrite this as a single combined log. So my log is over here, so I need to rewrite this 3 log whatever as a single term. This 3 becomes my exponent. So this is actually log x plus 4 to the third equals 6. Now remember, there's a base 10 here. So in order to solve this, I need to get rid of the log. So this base 10 is going to move over to the 6. So I get x plus 4 to the third equals 10 to the 6th. To continue, I need to move the exponent off of the x plus 4. I do that by essentially dividing the exponents by 3. So this just simplifies to x plus 4. And this now is 10 6 to the 3rd, or 10 squared. So we have x plus 4 equals 100, because that's what 10 squared is. Subtract 4 from both sides, and we get x equals 96. Now they want us to verify, so that's what we're going to do. So plug in the calculator, what 3 log of 96 plus 4 equals. So when you do that, log 96 plus 4, we get that this equals 6. All right. So again, we're doing basically a combination of everything that we've done in these past 2 units. Because remember, not only are we going to have to know how to condense the log term into one expression, and not only are we going to have to be able to transform the log term into an exponential equation, but we might also have to do stuff with exponentials, like dividing the exponents over, or like moving it over so that we can simplify. All right, so here's some practice questions. Here we have ln x equals 6. So I don't need to do anything to combine this, so I can actually just leave it like ln of x. All I need to do is rewrite this as a exponential. Remember, the whole point of ln is that it has a base e this time, so I move the e over. I pretty much have the same thing. This time I actually have to plug this into the calculator. A lot of the other math you could probably do with a simple one, but you really need to be able to do this. You won't be able to do this by hand. So we end up getting that x equals 403.43. Again, we can type this in, ln of 403.43, and we get that this is equal to 6.123452991. So yeah, this is essentially equal to 6. All right, so down here, now we have multiple log terms. So my first step is to combine them. There's no coefficient, so I don't have to deal with exponents, but I do have that these are being multiplied. So log base 9 of x times x minus 8 equals 1. Let me just simplify this a little bit. So x times x minus 8 means I'm distributing this x to both terms. So this is x squared minus 8x equals 1. Now I want to rewrite this. I can't really do anything else, so let me move the 9 over, drop the log. So that becomes x squared minus 8x equals 9 to the 1, which is just equal to 9. Now I can subtract the 9 over, and I get a quadratic. From here, I can factor this. So this factors as x minus 9, x plus 1. And this gives me the solutions that x equals 1, negative 1, and x equals 9. So we end up having 2 numbers that, again, we could plug in and test it for ourselves. Now, it is extremely important that you make sure that you remember all the different things that we've covered in this class. Unlike some of the other classes where it's perfectly fine to not remember what you did in the 3rd quarter or the 2nd quarter, this class is constantly building upon the previous work. So just as you saw here, we had to do things with quadratics, which was something covered in the 1st quarter of this class. In fact, it was about the 1st or 2nd unit. So all the previous units get brought back in different ways. Though the good news is that it's the simpler things. Typically, if you're going to see something like this with logs and it turns into a quadratic scenario, it's usually going to be able to be simplified through factoring rather than using the quadratic formula or completing the square. All right. So let's do a few more independent practices. So here we have, so now we have two log terms. There's a really interesting thing about this, and it's pretty much that the same thing applies if we had this setup. So if you recall, when we had exponential equations set equal to each other, if they have the same bases, we can set their exponents equal to each other. Well, the same thing applies here. Since both of these are log terms, they both have the same base, 10, I can set the insides equal to each other. So I just solve this for x. I get 3x equals 9, x equals 3. So to verify, we're going to see if log 5 times 3 equals log of 2 times 3 plus 9. 5 times 3 is 15, so this is log of 15. This is log 2 times 3 is 6 plus 9. And yeah, 6 plus 9 does equal 15. So we end up getting log 15 equals log 15. Perfect. So that was my solution. Whoop. All right, so here they want us to solve this for x to the nearest hundredth using the graphing calculator. So the main way that they want you to do this, if you find that you have something that's a little bit tricky. So here we have the variable both here under inside the ln term and over here. The only real way or the best way to actually solve this is to take a graphing calculator, type in the function y equals ln of 2x plus 4 and y equals x squared. So plugging both of these equations into the graphing calculator, one of the things that you can do is that you can put it into the graph mode and look at where they intersect. So when I do that, I end up getting that x equals, that they end up intersecting at x equals negative 0.89. Actually, let me write out the whole number. Now they want us to round to the nearest hundredth, so that's this point. Because the 2 right behind it is smaller than 5, we're just going to leave it as 0.89. And we can double check this. We could do ln of 2 times negative 0.89 plus 4. And we get that this is equal to 0.7975. And then if we do negative 0.89 squared, we end up getting that this is also 0.7921. So we get a slight difference, but that's just because we rounded this entirely long number to only 2 decimal places. And we see that within 2 decimal places, they are the same. So that's pretty much the main way that you're going to go about solving anything that's super complex. Again, if there's only one unknown variable or all the variables are in the log, you don't have to do that. We only have to do that because we had multiple log terms, multiple different places for that variable x. So let's continue doing a few more questions. Here, I can leave this combined for now. So I'm going to move the 5 over to here, drop the log. We get x plus y equals 5 squared. This simplifies to x plus 1 equals 25. Subtract the 1 over, and we get x equals 24. Over here, what I'm going to do is subtract the 7 over to the other side. We had 2 ln of x equals, that's supposed to be 7, negative 1. We can actually divide both sides by 2. That kind of makes our life a little bit easier. So this is negative 1/2. From here, remember there's that base e here. I can get rid of the ln by moving the e to the other side. So I end up getting x equals e to the negative 1/2. So I can plug this into the calculator, and I get that x equals, and they want us to the nearest tenth, so that's the first decimal place. So this is going to be 0.6. All right, move on to this one. So again, we have this base 3. We're going to move it over since there's nothing else I could do with the log. So I'm left with x plus 1 equals 3 squared. This simplifies to x plus 1 equals 9 minus the 1 to the other side. And we get x equals 8. Over here, what I'm going to do first is actually divide both sides by 4. So I end up getting ln 3x equals 8 divided by 4, which is 2. I'm going to take the base e here, move it over so it's underneath the 2, drop the ln, so I get 3x equals e squared. I can divide both sides by 3, and I get x equals e squared divided by 3. So plugging this in, e squared divided by 3, I end up getting that x equals 2.5. Remember, we're rounding to the nearest decimal. We'll do these last two, mainly because it ends up just being the same thing over and over. All right, so I'm actually going to divide both sides by 2 first, get the ln by itself as much as I can. Take the base e over here, move it to the other side, drop the ln. Get x equals e to the 3/2. So when I plug this in, I get x equals 4.5. And then the last one, I'm going to add 10 to both sides. So I get log base 3, x plus 3 equals 0. I'm going to take the 3, move it over to the other side, drop the log. So I get x plus 3 equals 3 to the 0. 3 to the 0 is just 1. So x plus 3 equals 1. Subtract both sides by 3. And I get x equals negative 2. All right. So there's a few more questions that you can do in addition to homework. So there's these few questions. You know what? Actually, I want to do number 9, mainly because this one's a little bit different than what we've seen. But 7 and 8 you can complete as well, in addition to the closure and the homework. So let's go and do number 9 real quick. So here's an equation that's dealing with the cooling of a hot cup of chocolate after a few minutes. They say that K is some constant, and they want us to actually figure out what K is. So it says that when the hot chocolate is placed in the room, it initially has a temperature of 68 degrees. So T0 is 68 degrees. They say after 3 minutes, so this is going to be equal to 3, the temperature becomes 150. It's kind of odd that it's getting hot, but all right. So what we're going to do is do ln of 150 minus 68 equals negative K times 3 plus 4.718. All right, so this one's going to be a little bit weird. Where the easiest thing to do is actually just plug into the calculator what ln of this expression is. So ln of 150 minus 68. So this is 4 point, they want the nearest thousandth, which is 3 decimal places. So that's going to be 407. And that's going to be equal to negative 3k plus 4.718. I'm going to subtract both sides by 4.718. So when I do 4.407 minus 4.718, I end up getting negative 0.311 equals negative 3k. Divide both sides by negative 3. And I end up getting that k is equal to 0.104, rounding to the nearest thousandth. All right, and that's pretty much it. So again, finish answering the rest of the questions. If you have any other questions, let me know. If some of the stuff like from the previous topics didn't make sense because I went too fast, make sure that you go over them, rewatch the videos on quadratics, on solving exponential equations, on condensing log terms, on rewriting all the exponential and log laws, all that stuff. And if you want, you can always reach out and we can do some extra help over, Google Meet or Zoom. All right, if you have any questions, let me know. Otherwise, good luck and have a great day.